on turbine induction, the other on turbine cooling. And then, hopefully, let me know if they're not. The course presentations should still be up in 171 turbine class. If one of these subjects are like, oh man, I totally forget that, you can go back and study that. So the way I'm going to do some of this, I'll just remind you and refresh you, but some of it, I'm going to start with a blank slide, and I'm going to ask you questions to see what you remember. So, inlets for turbine engines, what are 3 ways they can be mounted on the aircraft? What are kind of 3 classifications of mounting our inlet? Excellent. So like fuselage mounted? Yeah. Excellent.
Wing mounted.
Wing mounted. And then other one. Look at that. Oh my goodness, I'm so proud of you. So engine mounted, and not just right in front of the engine itself, or inlet. Wing mounted, so this is in the wing, going to the engine, and then fuselage mounted. So we've got a Hawker Siddeley Nimrod.
That's a good one.
And a MiG-15 up there. So some unique aircraft. So any questions on how they're mounted? Should be just like, oh yeah, reminder. And many versions of all 3 of these. So then, subsonic versus supersonic. Could someone, and talk about airflow, describe to me pressure and velocity of subsonic air through this venturi? I think your hand up was first. Yeah, hand was up first.
So subsonic pressure increases in the converted duct. That velocity increases.
Very good.
Pressure reduces.
Yep.
Supersonic is the other way around.
Very good.
And divergent is opposite of everything.
Yeah, so Sam, I think you had your hand up next. What kind of inlet is this? Yes, diverging. So what's happening with pressure right in here? Excellent. Excellent. So and this is how our beach jet engine nacelle inlet is. It's a little hard to tell because it's not a big difference, but it does diverge a little bit so that in the inlet, this pressure is going to be higher because that's how that is designed to get all the pressure we can to our compressor.
Does it also converge a little bit with the spinner?
Yes, because that comes in, yeah, a little bit, but this outer has more of an effect overall on it. But that's a very good observation, yes. So here is supersonic airflow. So now exactly what Leo said, it'll be opposite. Velocity decreasing, pressure increasing on supersonic, and then velocity increasing, pressure decreasing. So what do we do with inlets on really cool jet aircraft? What can we do with them if we're starting off subsonic, obviously, and then increasing to supersonic speed? What is something we can do? Type of inlet. Yeah, what's that? Very good. Change the shape by making a variable geometry inlet. So we start out getting all the airflow we can at subsonic flight, making it slightly divergent. And then, when things reverse, we can, let's go here. Someone talk to me if this is a supersonic aircraft, or we're having supersonic air come in here. What's happening with pressure, velocity? What's this trying to symbolize? said, now we can widen that out to increase pressure. But that is, they design these, and this is super smart engineers. They know how to shape this. They've done lots of tests so the shock wave happens at the right place. Poof. Now we have subsonic air. And this concept is what you can change the geometry so it can be doing whatever you need, whether you're starting off subsonic and then transition through to supersonic. And here is what it can look like, I believe, on an F-14. And here we're going, that has it in kilometers, 585, but you can see we're open as much as we can be. And then as he increases through transonic, start to close down, and then supersonic, now we've changed that inlet. So, let me find the name in my cool. How about when an engine with a subsonic divergent type inlet duct is running in place at high speed on the ground, so aircraft's stationary but the engines are high speed, high RPMs. The air pressure within the inlet is it negative, positive, or ambient?
I'm not 100% sure. I would guess.
So he's suggesting guessing negative. Whole class, I want you to vote. So how many would say it is negative? Uh-oh. How many would say it's positive? How many say it's ambient? And those of you that said positive, why?
Because it's greater. Pressure
Yeah.
increases, velocity decreases.
Because of that diverging shape, it does make the pressure more. It can be confusing because often people think with the engine spinning at higher RPM is sucking that air in. And yes, it is drawing air in, but because of the divergent shape, it's increasing pressure. Does that
I
make
think
sense?
it was positive, greater, like, I don't think
Right,
it's a
right. Yeah, positive means like more pressure. And then negative means low pressure.
and positive relative.
Yeah. Bell mouth, we talked about these guys. Why would we use a bell mouth inlet duct? And what is its purpose?
Because it's a converging duct, so you want a lower pressure, but you want to draw air in because of the spinning rotors.
Good. So yeah, it's used on helicopters. And what else is it used for?
So it's per test.
For test stands. And that's because helicopters are relatively slow with high power, and so they want to get more velocity, more airflow, as well as on a test stand, you're just sitting there, so they're trying to get more air into it, and it is a convergent duct. So therefore, Charlie, the purpose of a bell mouth compressor inlet is to provide an increased ram air effect at low air speeds, or maximize aerodynamic efficiency of the inlet, or provide an increased pressure drop in the inlet. Which one? How many would agree? Oh, hey, you got some agreement. What other answers?
Bravo.
Bravo. So yes. What is the definition coming in. So since it's stationary and it's not, to create a ram air effect, you have to be moving the whole thing faster to get ram air. But it does maximize aerodynamic efficiency to get more air in. With our jet turbine aircraft, especially our turbofans, don't forget, if you ever go to work for the airlines or anything like that, they can be very hungry. You've got massive airflow, drawing in huge amounts of air. They will devour anything that they please to not tie down with. So, I think y'all had a second to look at this. I was going to ask you this one. So, do we put filters, or very often do we put screens on turbine aircraft?
No.
Right. Because why would we not put inlet screens on like turbofans? Too much restriction. What's some other things?
The duct hits you to floor clear.
I'm getting pictures of shredded duck.
You have ice build up on it?
Exactly. It'd be very susceptible to ice buildup, and or not a good way to clean that off, and then it would ice build up and break off and nom nom. And also the screen, if it fails, then nom nom and owie. So the biggest thing is we can't restrict the airflow, but then yeah, ice could build up on them. What type of turbine engine does use an inlet screen? PT6. So smaller turboprops don't have as massive airflow, and you can have very coarse mesh screen like this to cover the inlet. And oh, here's bonus. Anybody remember anything unique about how Pratt & Whitney makes the size of their mesh? Exactly, to prevent any of their hardware from getting ingested. So if hardware's in there, it's not theirs, you did something naughty. But particle separators can be and are used on turboprop aircraft. Does anybody remember how a particle separator, they are also called ice vanes on our King Air, depends what airframe they're on, how they work?
So the air is like going so fast and it shoots it straight up, and the particles have too much inertia, so they can't go up, so then they drop out from that.
Very good. So it's based on inertia. The air is going to follow the big old vacuum cleaner, so that's going to get sucked up in there. But all these particles, because of the sharp changes of geometry, and there's a big old plate in the way, then the particles are going to, I can't make it, boop, out they go. And these would be out if you think you have pieces of ice coming, or if you're operating in a dirty environment. Otherwise, you keep it up, so it restricts airflow a tiny bit. So you would have it up and you're fine. What about a vortex dissipator to dissipate that? How does that work? One person, okay, people raise your hand, one more answer.
Bleed air.
Gavin was actually raising his hand rather than just saying the answer.
Doesn't it blow bleed air out into where the vortex is?
Exactly, so it takes bleed air and blows it out into where the vortex is occurring. And what allows the vortex dissipator system to be activated, or does it just like use bleed air all the time? Hello. Landing gear actuators. Yep. So it feels weight on wheels, and it's like, oh no, I might be sucking up stone from the ground, and blows it away. These are pictures I took when Emma Kodiak was here, and you can look up in there and see the ice vein. Cool thing King Air, it just dumps out the bottom. But on the Kodiak, because that goes back inside the fuselage, so our belly pod needs special ducting to allow all that dirt to drop out the bottom. So if you see those little pipes coming out the belly pod, that's what it's for. And tidbit, whoops, next slide. So here is our main engine air inlet. What do you think in cooling systems this little duct on the side is for? Yes? And what is it for? Exactly. It'll take this air and duct blast tubes onto components that tend to get hot. So, Sam, what methods are or is used to provide clean air to the engines of helicopters and turboprop planes that have particle, sand and ice separators installed? Very good. Sharp airflow, directional change to take advantage of inertia, force, centrifugal force, filters, and engine inlet. And neat. The vortex dissipators installed on some turbine-powered aircraft to prevent engine fog utilize variable inlet guide vanes or variable first stage fan blades, or variable geometry inlet ducts, or a stream of engine bleed air blown towards the ground ahead of the engine.
Charlie.
Yeah. And John. Vortex dissipator systems are generally activated by
Alpha.
landing gear switch. Okay, hold it. Corbin. Using compressor bleed air directed into a nozzle, a vortex dissipator's primary function is to, yeah. Those others are very interesting.
That's a big picture.
I'm pretty sure it's,
There's no one that's up there with that.
That's very small.
so if it crash landed and the landing gear broke and happened to go into the engine, maybe. But it was a very fun picture. Oh, okay. Now, anti-ice systems. So with turbines, we want prevention. We don't want ice to build up and then break it off, because where is it gonna go? Nom nom. So prevent it, keep it heated. No de-icing, just anti-icing. So, very often we'll take high temperature bleed air from the compressor and duct it out to our inlet. However, the downside of that is it does decrease engine power output a little bit. We're sucking off that bleed air. Yes.
That was a bit of a maybe theoretical question. Which actually takes more power? Like the converting heat air or converting power to generators?
Right, and it's a very good question. I don't know the answer to like power itself. This has more effect on, you'll see more effect on the engine. And what kinds of indications but on bigger jet engines, we can have like a stage 5, like this Gulfstream. So we duct it off, then we have a venturi to control our airflow. Duct it up to the front, where it can go around. And then we have lots of valves to regulate that. But just very simply speaking, and this is where most of where you'll be looking at it on the beach jet, is following this ducting, making sure that's intact.
Would that be specifically for anti-ice since it's hotter than?
Yes, yes.
The higher the.
Correct. They will. They will go back further, and they'll probably be using this for other stuff too. But yes, they do go back to where it's the hottest. The jet.
What I missed is, but is it just heating the edge, or is it making like a force field? Like how they do on the roof? I think that, you don't have to answer that.
There is.
Everybody just laughed.
There is in a video that I have next. It shows you kind of the internal passages where it's going.
It's just heating the edge.
There is kind of a gap in here that it'll like heat up.
But it doesn't come out with it, right?
Yeah.
Like when
Right.
the beach jet windshield is.
Oh, right, yeah. Yeah. No, it's like internally heating it up from the inside. So I like
That's probably the end.
okay. I have a short portion of this video I'll show you. Just hitting the bleed air section of the anti-ice. He goes through all the anti-ice stuff.
Wix gives you the power of AI to build the website you need. With full
Dear friends and followers, welcome back to this follow-up video on how airplanes deal with cold weather. The icing system is needed. Now the system for the engine anti-ice works very similar. The engine intake very often has this shiny alloy lookalike surface. That's the engine anti-iced area. Again, hot air is extracted via the engine anti-ice valve from the high pressure compressor stage and is piped forwards to the engine intake. The hot air is then distributed through this pipe with these little holes, heating up the intake lip and melting any accumulated ice. And once it's done, the hot air exits via this outlet right here. And the ECAM displays engine anti-ice, and at the same time the turbine ignition system is set to continuous to prevent any engine flame out should a lot of water be injected. Now you need to take special care in case of rapid ice buildup, because as you press the engine anti-ice button, chunks of ice could get sucked into the engine and damage the fan blades. So why not leave the engine and wing anti-ice turned on throughout the entire flight to prevent ice from building up in the first place? The main concern, as so often, is fuel consumption. When you turn on the wing or engine anti-ice, the FADEC increases the engine's power to provide constant pressure to all other bleed air distributors, thus increasing the fuel consumption. Now let's look at other anti-icing systems. Turboprop planes like the Dash 8 Q400, for example, are fitted with the so-called de-icing boots system, which is also based on bleed air supply extracted from the engines, and you can easily recognize these planes fitted with the pneumatic boot system as their leading edges come with a black rubber coating. And once you have visible indication of ice, you actually wait a few minutes to let the ice build up a few layers.
He doesn't talk about engines anymore. Sorry.
layers.
Micah. Oh, actually not Micah. This isn't anyone. I'm going to put you back here in here. Because this is the one I don't like. What engine instrument indications may shift when a turbo... So it may shift. That doesn't necessarily mean just a rise or drop, just like you see a boop boop. When a turbofan engine anti-ice bleed air system is turned on. I heard a confident beep. But will you see a shift in fuel flow? Anyone?
Yes.
Yep. Will you see a shift in EGT?
Yes.
Will you see a change in EPR?
Yes.
Will you see a change in tachometer? Yes. So this is here and here. This is there. That's in all three of them. This is so. They say it's C. I know. Like they act as though fuel flow isn't a thing, and that's just wrong. So hopefully you take your writtens back, because this is from Prepware. So hopefully the FAA actually has it correct in their written, and it will be, because all of these answers are like yes, I see, yep, all that, yep, all of that. So
Wouldn't all of them not shift? Like meaning, wouldn't FADAC take care of it after a while? Like, I guess fuel flow would stay higher, right? But every EGT, EPR,
right.
TACOM, or
That could be
FADAC
what
would
they're
take care of
getting
that,
at.
right? Initially, you might see it, but
Although EGT would rise and stay higher, because that's a very good thought. Like you could say fuel flow would just go up, the rest are like a boop boop kind of a boom, but it would still rise, yeah. So if you sort it out, let me know. But so Playo. The purpose of an engine inlet anti-ice system is primarily to yes, prevent, not remove ice. Turbine bleed air. Where do we take our bleed air from? What's that? I like that. Yep, maybe. What component? Compressor? Yep. Compressor, and it really depends on the engine. It might be 2.5, it might be 3, it could be 5, depending how stretched out it is. And what all, try to do one at a time, what all sorts of things do we use bleed air for? Oh, raise your hand. Yeah. Starting other engines. Yes. What I say? Pressurization, cabin pressurization. Wow! And some others.
Heating.
Heating, yes. Engine starting, he got that. Bearings, yes. Gold star.
Cooling.
Yes.
Engine,
Yes.
say that. For windshield, rain, blast.
Yeah, the force field.
I said it. I said engine cooling. Cooling.
Yes. All right, here we go. Whoops, never mind. Here we go. So, fuel systems, if you remember the PT6 fuel control uses bleed air pressures. The seals, pressurized hydraulic reservoirs, vacuum for instruments, pressurized door seals, cabin pressurization, operate autopilot, de-icing, and then heat and cool the cabin. On the super fast review, is there any questions in that? What is the hottest section of turbine?
No.
like I think
Like a bunch of robots.
I think you all got it. Turbine inlet, first stage turbine inlet, guide vanes, otherwise known as nozzle. secondary air system. So yeah, fuel, seals, all of that stuff. I'm gonna make me so proud of you all. So yeah, about 75% used in general for turbines. Hottest section, first stage turbine nozzle guide vanes, right after our burner, right about in there. And don't forget that we conduct this air to cool. What do you think these thingamajigs would be?
What?
Turbine blades.
Turbine blades?
The
Oh,
roots.
what's that?
The roots. Fir tree.
Oh yeah. Actually, very good. Yeah, that is a fir tree attachment. So we can use that to cool our turbine blades and also our stator vanes. So our first stage turbine nozzle guide vanes can be cooled that way. Here is a diagram of our beach jet engine, a JT-15. So our core airflow comes through here. Oh my, what do you think this is? So we come through our compressor. Yes, I heard it, diffuser. And it comes into our combustion and out. And then what is this airflow here? Yep, fan bypass air there. And then here is where all our cooling air to all our accessories go. So it comes up here and goes in for all our bearings and seals and cools all our vanes and turbine blades. Here is the guide vane, it's cooling that. We just very quick peek at that. And they also want you to know that there are baffles in jet engines. So, and they can be different places. So here we have our high pressure turbine stator assembly with the large and small exit ducts. So as it comes through the burner, then it makes that turn. This is what's deflecting that back. And those can be called baffles sometimes. Here is our second stage low pressure turbine stator assembly. And we have stiffening rings and baffle support and some baffle just kind of between components to direct airflow, help the right things get cool. And here's a quick little video of airflow through a JT-15. And you can kind of see all the inner Thank you. We know it's a JT-15. One other thing we need to talk about is blankets. So some turbine engines use insulation blankets, not to keep it warm, but to keep it cool, mainly to protect the really hot parts, or to protect the non-hot parts from the really hot parts. So this is more so used on early engines because they have better cooling designs now, but it would reduce the leaks, keep anything leaking from hitting the hot engine part, and also make a barrier between the hot engine part and parts you don't want to get so hot. Shields the rest of the engine from the exhaust duct, and typically there'll be layers of stainless steel shroud, fiberglass, aluminum foil, and then more fiberglass, silver foil, and just layers to protect that. Don't need to know too much other than they are part of a turbine cooling system. So hopefully that was a good review. Any questions on any of that? Kind of sailed through it pretty quickly. Hopefully it jogged your memory. If you haven't watched Princess Bride, it's I recommend it. That's pretty ridiculous. But anyway. And that is the end. How about take a quick break, come back at 12:30, and then that gives you time to open up your very last labs, talk about labs, so come back at 12:30. Yes. Mondays are fine.
Truck or split induction cooling, and then, wait,
Turbine. I think.
oh, okay.
I don't know if induction and cooling used to be separate. I think it might be together now, but then turbine air system is.
This is officially induction.
Like a two separate chapters.
Yeah.
But I think where the most is.
Ready to never ends. Week and a half.
You know anything about Honda turbo turbine?
Oh, I've heard about it.
Said Oshkosh handles with this one. We were trying to figure out where fuel is going. That looks like it's lighter there.
Yes.
And that looks like it's probably fuel line. Then it went down. The internally routed. It went down to a
wonder.
carburetor looking thing. Obviously it's not a carburetor.
Right.
It went into like a little device that looked like a carburetor.
The big old giant turbojet that we have fighting over 90s hangars, it has a kind of like that, where it comes down to one main, and then inside are all the fuel nozzles. It's vacuum.
Huh.
So that could be how it is, which is, I don't know, how I can tell you, it might be nightmare. They have like split the
Yeah, you'd
engine.
think.
Like, I don't know why.
Oh, another thing I just thought of one day, on that cutaway of the anti-ice on the engine, was there any reason why they had one and a second one? Was it just so that air is evenly distributed, like it pressurizes it before it?
I think so.
Because I'm like, well, actually, that's more weight, but it's probably
Right.
more evenly.
Yeah.
Hey, just under your Dude, I got a hole there. I got some ventilation. You want another? Nah, dude.
Surgery for that.
Hey, do you ever safety your foot song? I did. Yeah. Work decent or not? Like I can still make it move. Do you use the 32 or? I did a double wrap, single wrap, and single. Oh, wow, please do.
started lab 9, which is in 2 parts, part 1 and part 2. Part 1 is mostly Moodle questions, so go according to what it tells you to do as far as resources. Question 8 is a practical. It says in your assigned group. In your assigned group, inspect the inertial separator ice vane, anti-ice vane, on the Beechcraft King Air U-21, left or right, in accordance with the maintenance manual. So grab the maintenance manual, follow the inspection that it tells you to do. Actually go out to the aircraft, look in at it, and you can, since this is in your assigned group, one person can go into cockpit, actuate it, make sure it's doing what it's supposed to be doing, and then check linkages, but it won't take very long, so that'll be a fairly quick lab. And then part 2 is just a practical, no Moodle questions, and this is on the beach jet. And rather than doing a whole bunch of things, we broke this down into parts. So, for the induction portion, you're gonna just look in the front of the engine, see what you can with the compressor, fan, inlet, cone assembly, checking your inlet duct. Please take out whatever you need, whether step stools or ladders, to gently get up on the wing, throw down a blanket to protect it. Please treat it as a good and nice airplane, because it is a good and nice airplane. So I don't want you tromping up there with your boots, messing up the paint, unless you want to stay for next year and do paint classes. And then you're going to do the nacelle anti-icing duct inspection, and it says to include removal of the ram air intake duct. This is very specific because this is exactly what's in the manual. So you would go to the manual, look up nacelle anti-icing duct inspection, and it'll tell you what to do. In those steps, it'll tell you you have to remove the ram air intake duct to access the anti-ice duct. It's pretty clear. Once you find those 2 sections in the manual, it'll step you through very nicely what to do. And then you're going to do the engine air intake anti-icing system functional test, which is pretty much that wording, very close. If you word search that, that should come up in the manual. Functional test, you're going to go in the, going to get power, go in the cockpit and hit the anti-ice button. See in from the manual what indications you should get. Not turning the engines on, just without engines running and at the specific test in the manual. Then it says engine bleed air system inspection. I saw a couple people go, ugh. If you were to inspect the entire bleed air system, that would take probably a couple of days, I would think. Because there's tons and tons of stuff. I would take tons of stuff off the engine to inspect every single part of the bleed air, stuff in the cabin, up through the cockpit. So, that is just to make sure you are inspecting the bleed air system that is part of the anti-icing. So when you're looking at the anti-icing, just make sure, as far as you can see with the bottom cowl off, you're looking at that bleed air duct. Don't take off more than the bottom cowl. Just what you can see with that off. So, not that much. And then you'll do a logbook entry. With this one, it can be a little tricky at first. So once you think you understand it from the manual, after you pop off the bottom cowl and kind of see the components, before you actually remove anything else, talk to me and tell me what your plan is, and I can say, yep, that's exactly right, or I'll be like, actually, no, this here is what you want to do here and there, because you could mess it up if you start, and waste a lot of time if you start taking the wrong things apart. So make sure your group checks with me before you go further than just taking off the bottom cowl. And I'm also going to start putting groups through. Was there any questions on the beach jet? Or doing a cooling system inspection, make sure you look at cowl flaps and actuate those cowl flaps. Check the rigging. Do not change the rigging if it's wrong. Just check it, inspect it for where it's at. The cowling and the baffles, in accordance with the 414 maintenance manual, will have the cowl flaps because that's airframe item. And then the Continental Mo manual has excellent information for cowling and baffles, especially the baffles. So you'll be using both those resources for that. Any questions on that? All right, here is numbering. Okay, so today, first up on the beach jet is going to be Zach and Sam, and you can take the right engine. Trevor and Parker, you can take beach jet left engine. And then after that, it'll be Corbin, Nate, David, and Gavin. Hopefully, Peek and Joey, Austin, Elijah. Make sure if you're in these groups, you're getting into the manual ahead of time, so when you're called, you can be ready to go. Trevor and Parker, once you're done beach jet, you do the Apache augmenters. Corbin and Nate, you should have time to do the U-21 ice before you do the beach jet. I would say get in the beach jet manual first, kind of know your resources. If you're not caught out yet, then do the ice, because you'll have time after that also. And then same for David and Gavin. David is back. Look at those people. Get your beach jet information, and then do the King Air ice. Leo and Sydney, you're up first. Yes, up first for Cessna 414 cooling, so I'll just give you right engine. And then John and Anthony, I'll put you on right away on left engine for 414 cooling. And then Leo and Sydney can do King Air ice after that. And John and Anthony, after you do the cooling, you can do the augmenters. Micah and Stephen, you guys can do baffle seal, and just pick any section of it and then let me know when you're done. And then the augmenters, once you're done with that. Charlie and Dan, what's the story on the stubby?
Still trying to write it.
So I'll get with you and kind of see where we're at. Hopefully you can get that finished up and then do the ice. But yeah, I'll talk with you and figure out something. And then, oh yeah, Josh and Avette. Yep, keep going on the Cherokee. And then once you're done with that, baffle seal. And Isaac and Harrison. So these guys will have to get done. I'll probably put you on the Cherokee once they're done. So first, we'll see. I hope I can throw you into the cooling. But I would say get started on the baffle seal first. Do that, and then I'll pull you into one of these. And Elijah Austin, you can knock out the ice before you do the beach jet. Ryan and Lee. And I'm not going to assign right or left engine for ice, because I'm not sure when people will get out there. Once you're out there, if somebody's there, just wait. It does not take very long. And just cycle in whichever side is available. Any questions? Yeah.
So I'm looking at the beach jet lab, and like just like logbook entries kind of in the future and for this class, like if you're doing like a specific phase A inspection, what it says, can you write that in the logbook as in like performed like a phase A inspection, or do you actually have to list everything performing the above inspections as part of the scheduled phase A. So then in our logbook entry for this class, do we have to list all of those things and say that we inspected all of those, or can we just say like we just did the phase A inspection? Even though it's a part of
Right.
it, I'm asking if we have to copy it.
Very good question. So for my class, because I want to make sure you're hitting all the components, for my class, this class, I like you to list components. However, if you're working at a place that does this, they would, like the FAA has to come in and approve their phase inspections, and they would say phase A is yada, 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 yada. They had that documented somewhere, and so you would just put in accordance with phase A inspection, because they know they've approved that, that's documented right now. Did that answer your question? I was like, do this, but this is what's normal.
Yeah.
I still have quite a few people needing to do the turbocharger explanation, and you can, as if you're not assigned to a group, you can try to work that in. There'll also be time for that tomorrow. But yeah, if you're not actively doing a group lab, grab me, we can go through the turbocharger inspection. We'll work around the people that are doing the cooling inspection. Totally fine. Don't forget the Cessna 182. You need to see me once you find a very specific fault. And then you're all doing good with filters. Just a couple more people need to do their filters. So you're going very, very well with the schedule supplied to you. I appreciate it. Any questions?